All right, in order to do these examples here, where we're going to find the amplitude, the period, and write the equation, first we're going to have to do is be able to determine what we're looking at. Is this a sine graph? Is this a cosine graph? Okay. So in order to do that, what we're going to do here is let's look at the two graphs that we graphed. Here's the sine graph, okay, and here's the cosine graph, and you can see they basically look the same. Really, the only difference is that this graph, if you shift it back a little bit, then this point can come here. So this whole graph here is just shifted off to the side. Now, the way we can really tell the graphs apart is look at the origin. Here, on the cosine, the graph starts at positive 1. On the sine, the graph starts at 0. Okay? And then from here, the sine graph moves up to positive 1. On the cosine starts at positive 1 and heads to 0, which is actually what happens at this point on the sine graph. So sine starts at the origin, cosine starts at positive 1. Okay? So let's sketch that out for ourselves on our notes. Okay? Let's get a quick sketch here. We know that positive sine graphs, okay, positive sine graphs would start at our origin, and then the graph's going to go up to positive 1, down to 0, down to negative 1, and then back to 0. That's what a positive sine graph does. If you put a negative in front of our sine graph, just like if you put a negative in front of any graph, remember, parabola opened up was x squared, and then down was negative x squared. So if you put a negative in front of the sine, what's going to happen is it's just going to flip. So it's going to start at 0, go down to negative 1, go up to 0, go up to positive 1, and then back down to 0. So that's going to be your sine graph. Your cosine graph, on the other hand, positive cosine graph is going to start at positive 1 and head to 0, go down to negative 1, back to 0, and then back up to positive 1. Negative cosine is going to start at negative 1, head up to 0, go up to positive 1, back to 0, and then back down to negative 1. Okay? So, you can tell sine and cosine apart based off of where they start. Sine starts at the origin, cosine either starts at positive or negative 1. So, on the first example here, we need to first decide what are we looking at, sine or cosine? Well, here's our origin right here. And it looks like the graph goes right through the origin, so this is going to be a sine graph. We know that this is going to be y equals something sine of something theta. And we need to fill in those two pieces of information. We need to know the amplitude and the number of cycles. Okay? So let's find our amplitude. Our amplitude here, since this graph is perfectly centered on the graph, it's going to be how much does it go up and down. So it looks like it goes up and down positive 2. So our amplitude is 2. So our amp here was equal to 2. And then our period, again, period is the length of a cycle. How long is the cycle? Well, if it starts here, looks like it's stopping here, because remember, it looks like it's going down. So when does it start to head down from the x-axis? Well, it starts to repeat at 3 pi. So from here to here, this is one cycle. So this is 3 pi. That's the length of one cycle. Easiest place to measure from is start at 0. Just like if you were measuring on a ruler, you would start at 0 and you would count. So if you start from 0, count across, and you find out that your period is 3 pi. Okay? Now, the B does not represent your period. It represents the number of cycles. So we know that the period is equal to 2 pi over b, well, that means if the period equals 2 pi over b, and we know what the period is, then we should be able to solve for b. Well, if this was a proportion, these two values would get multiplied together, so it really doesn't matter where they're at, so we could just interchange them. So we can actually create a formula for b. b equals 2 pi over the period. And you'll probably want to add that to your notes here, that b equals 2 pi divided by your period. Okay? Because that's going to be useful to find your b. So in this particular case, b is going to equal 2 pi over your period, which is 3 pi. So there the pi's cancel, and you get 2/3. Okay? That means from 0 to 2 pi, that's 2/3 of a cycle. From here to here is 2/3 of the cycle. And you can see that, you know, from 0 to 2 pi here, this is half, this is the whole thing, so it's somewhere between half and a whole is actually 2/3. Okay? So let's try another one, and then we'll do the other ones in the next video. So this one looks like the graph's going through the origin again. So again, this is a sine graph, so this is going to be y equals something sine something of theta. Okay, so let's get our amplitude. Our amplitude here looks like we're going up and down 4. So our amp is 4, so this gives us 4 sine theta. And then what's our period? Our period in this case is the length of one cycle. Well, it starts here and then it stops here. That's the first cycle. What's the length from here to here? That's 2 pi. Okay, so our period is 2 pi. Now we need to figure out our b. So b again is 2 pi over the period. So this is 2 pi over our period, which is 2 pi. So pi's cancel. 2 over 2 gets you 1. So how many cycles are there between 0 and 2 pi? There's 1 cycle. Okay. Now something I just caught. We actually had a mistake here on this first one. This is a sine graph. But notice that the sine graph doesn't start going up like positive sine does. It actually goes down first. So this is actually a negative sine graph. So here, this is -2 sine of 2/3 theta. Okay? This one here is a positive sine graph. It starts going up first. It's a positive sine. So it is a positive 4 sine theta.